Hello, everyone. I think that we can wait for about 3 or 4 minutes for some more people, and then I think we can start the whole presentation. Okay, I think we can start. It's high time because we have a lot of slides and a lot of exercises and, well, not much time. So today I would like to tell you something about monitoring in big data platform. And okay, it works now. So at present, I'm working as the big data DevOps engineer in GetinData, and I also help several companies mainly in cloud projects. So I'm using all the public clouds and also the on-premise architecture. And at present, I'm mainly working with migrating all the stuff to the Kubernetes. So the whole agenda for the meeting is quite short, I would say. And after each part, there will be the time for Q&A session. So, and you can also write any questions in the Zoom chat or YouTube chat. And I will try to answer any question that will happen. So the first thing from which I would like to start is about monitoring. And the first thing is about comparing the push and pull model, because at present in the market, you can find several solutions and you can easily find the solution that will be the best match for your needs. And I think it's really important to show the main differences between the push and pull model. And for example, some examples of the services that uses the push model in the monitoring system are like Graphite, CloudWatch, or Google Stackdriver that now is called Operations Metrics, while the most popular service that uses the pull model is Prometheus, about which I will talk a lot because in our projects we use mainly Prometheus due to its scalability, performance, and that we can easily export any metrics that we need for our monitoring system. So the most important thing when we talk about monitoring model system is how we expose or push metrics, because in push system, we push these metrics, for example, from the in the Spark job, while during the pull, we expose the metrics that are read by the Prometheus. Surely there is also the push gateway about which I have also some slides, but about it we'll talk later. And there are some differences, and it's really hard to choose the only one right solution because it depends on the use case, in which environment do we need the whole monitoring system, and what kind of metrics we need. So I would like to start from describing the whole Prometheus. And Prometheus is an open source systems monitoring. It uses the time series database in which it stores all the metrics. And the components of the Prometheus are the server that scrapes data and save them to the database, client libraries, a push gateway for supporting short-lived jobs, and then we can talk about the mixed architecture of the push and pull monitoring model. And there is also an alert manager to handle alerts. And the last thing that I think is really useful for any developers is a special purpose exporters for the services, because you can write even your own exporter, like in a different system, and especially in some other like Nagios. And it helps in preparing the whole monitoring for the big data platforms, because you can't find all the required exporters that you need for monitoring your Hadoop cluster or any different platform. And the whole Prometheus architecture seems to be quite simple, because there is the Prometheus server, the time series database, HTTP server, and I think now I can show you the web user interface, but I suppose you know it very well. That's the last release of the Prometheus. And well, it works, and it's okay only for checking if it's up and if we have all the metrics to not run Grafana. And when we talk about Prometheus, we need to talk about several stories that we have in GetinData. The first thing is about service discovery. And well, it's great, especially when we talk about the Flink jobs. So when we talk about jobs that will use the nodes about which we are not sure that they will occur, this job, so we need to have the service discovery. So we define for the Prometheus only the path to the file in which we save the hostname and port. And it works this way in the on-premise infrastructure. In Kubernetes world, it becomes much easier because we can define which pods we would like to monitor. So we can define in the Prometheus configuration that we would like to monitor only the pods with the label, for example, job, Flink, e-commerce customers, and then the Prometheus will do the rest of the job. So Prometheus is really great tool when we talk about the Kubernetes environment, while in the on-premise, it requires adding some own scripts. And in one project, we use our own Python script that creates the JSON file with the list of all host names. The second thing about Prometheus that is really important is about providing the high availability, because by default, Prometheus is not designed to have the high availability well, it runs locally. And the second part is linked to the third, because do you need archive data? In some projects, it is required by some business analysts or any different people that they would like to have the metrics, for example, from the last 90 days. And then you shouldn't use the time series database that is installed with the Prometheus default, because it's not designed for this purpose. And the last thing is about monitoring Prometheus. It can also go down, and then we should get the alert. And about the service discovery, we can use several tools that enable something like this. And in the Kubernetes world, it's really simple, as I have mentioned, while in the on-premise, we can go with console or file-based. So we need to create the JSON file. Unfortunately, Prometheus is not the most secure solution because, for example, when we enable the admin API, then absolutely anybody that has access to the network and access to our instance can, for example, delete some time series. So it's quite important to not give many permissions to the most of the users. And surely, there are some talks about adding more security features, but at present, it's not the best solution when we talk, for example, about scrapping some targets from the internet. Surely we can go with some certificates and doing, but it requires more work. But in terms of the big data platforms, when we talk only about the private access to these instances, it's okay, and well, it works as expected. And well, it also makes a lot of sense that by default, this admin API is disabled. And now I would like to tell you something about the high availability of the Prometheus, because it's a really complicated story, and we tried a lot of solutions. In the Kubernetes, it's much simpler, also due to some installation, but in the on-premise world, we can go also with the simplest setup that seems to be okay in most cases. So the simplest architecture for high availability is about installing and maintaining the two Prometheus instances. And each instance doesn't know that the different exists. And both of them scrapes the metrics. And it also means that these metrics may have a bit different value and a bit different timestamp. And it's really important when we talk about it, because it can make a bit more difficult to create some dashboards. And you can also add the Promxy. That's the open source. So it's the open source solution, and the source code you can find, of course, on the GitHub, that enables adding the single endpoint for these two Prometheus instances. And well, it works as expected. But when we talk about high availability for the alert managers, they can cooperate. And well, they will only one of them will send alert in case of any issue or when any value of the metric will go over or under. And about the real high availability for the storage and also the solution for storing archive data, there are three main players on the market. So the first is Cortex from Grafana Labs, and it uses, for example, the AWS S3, Google Cloud Storage, or Cassandra. When we talk about the on-premise installation, there is also M3DB from Uber, and the last is Thanos. And Thanos seems to be the most mature solution at present, and it requires only the object storage. And it helps in making the whole Prometheus better clusterized, because each component works as the separate service. So now I would like to tell you something about the monitoring infrastructure. So I suppose that you do it at present. So the first thing is about service monitoring. And here we can go even with the simplest thing. So about the Node Exporter. And we can also write our custom exporters. And it's really important to add that we do not have to use the machine learning in the Prometheus, but IBM prepared something like this 3 or 2 years ago, as I remember, because here you can define some alerts that will be triggered when the prediction that the disk usage will go over 90% in next 12 hours will trigger the alert. And well, it works, and it's the most important when we talk the monitoring system. And also, I'd like to add one great quote from the book from Google about site reliability engineering, that the alerts should be sent only then the action that needs to once again, because well, I don't have the best memory, that the alerts should be sent only then when the human operator must take the action. So it's also important to not send alerts about absolutely everything, because from my own experience, I know that most people will disable the notification for any alert after 1 week or 2 weeks, when a lot of alerts will be sent to the Slack channel or to the email. When we talk about the Kubernetes monitoring, here we go again, that the Kubernetes is great, that the Prometheus is a great companion for the Kubernetes. And we can monitor a lot of stuff, like with any different solution. But it's also important that we can use the Node Exporter or kubestate metrics. And it is quite simple service that listens to the Kubernetes API and generates metrics about the state of the objects. And surely you can install Prometheus operator or the standalone Prometheus instance. And I would like also to add that there is that the Prometheus operator adds several useful objects for the Kubernetes. So for example, you can define the additional objects like the pod monitor, where you can define that you would like to monitor the pods with defined label, or the service monitor, in which you can define that I would like to monitor the service called Flink and Nginx or any different. And now it's time to talk something about the monitoring of the Hadoop cluster. So, well, when we talk the Ambari-based Hadoop installation, it seems to be quite simple, because there is the Ambari metrics system that takes the metrics from all components, and it shows them in its own Grafana. And well, you can also use the dedicated exporter that helps in exposing these metrics to your own Grafana, but it causes some problems. And for example, when we would like to create the new dashboard with Hive LLAP, it can't show the metrics, and we find the one bug in the code, but unfortunately we still didn't push the fix for this exporter. But we can also go with some different solutions, our own exporters. And the simplest is the JMX exporter. So we can take the metrics about the JVM from any JVM process, and it's really helpful when we talk about monitoring any component that comes from the Apache Foundation. And well, it works, but it also requires the additional YAML configuration file that is used to change the format of the metrics to make it Prometheus format compatible. So the one that is really well described in the internet is about adding the JMX exporter to the Kafka, because it requires using the JMX exporter. The last release is 0.14, as I remember, and it also requires adding the quite simple Kafka YAML configuration file in which we add the mapping rules for the metrics. And you can find there the number of the replicas under replicated partitions, state of each broker, and all the JVM metrics. And I would say it's one of the most crucial components in the big data platforms, especially that in most cases Kafka is under heavy load. And in my opinion, it's absolutely the must-have when we talk about the monitoring the Kafka, especially that this exporter adds much more metrics in comparison to the default one that is added from the Ambari metric system. And what about some applications? Because here I will mention also about Hive and different services that we use, usually in big data platforms. So now it's time to talk also about the push gateway that supports the push-based monitoring model. So the most common use case is about running the Spark job that will run for a certain period of time. So it will not work all the time. It's not like the Flink job, but it also depends on the use case. And when we have the short-lived jobs, we can go with the push gateway. And the whole pipeline is really simple because we push the metrics to the push gateway, and push gateway exposes these metrics to the Prometheus instance. But unfortunately, it has also some disadvantages as any service that you can find. The biggest disadvantage is that the push gateway never forgets serious push to it and will expose them to the Prometheus forever. So, for example, we have the short-lived jobs, and it will finish after 2 hours, and even after 3 hours, it will still expose these metrics to the Prometheus. Oh, okay, some network issue. So, okay, I think that we'll try once again. Okay, so we'll try with a little smaller screen. Or I will reload the whole presentation. Unfortunately, the Google Chrome solution. Okay, now it works. Also, now it's time to talk about the different services from the Prometheus ecosystem. And the first one that I really like is the Blackbox Exporter, and it helps in probing API endpoints, and it's also great to check if some of our websites leave, because it checks the HTTP code, because well, it runs the curl get, and we get the HTTP response code. So you can easily check if all the required services are up and can be accessed by the users. The next exporter that we use in our project is Airflow Exporter, and we can really easily install it with PIP, and it's also available in the GitHub. So you can add some of your custom code, and it provides required metrics for Airflow, so you can easily check the task status, run duration, and you can predict that there will be some issue with the job that is responsible, for example, for triggering the Spark job in the AWS EMR cluster, or that is responsible for moving some data from point A to B. There is also the Knox Exporter, and it's written in Java. That is quite strange because most of these exporters are written in Golang or Python. But well, it works smoothly, and it's really simple in configuring. And when we use Knox, it's really useful tool to check if access to the web HDFS and Hive works as expected. And well, we can also save time to not respond to the users that they can access, because well, we'll know even before them. Now it's time to talk also about the Apache NiFi from the release 1.11, as I remember. There is also the additional Prometheus reporting task that supports us in reporting metrics in Prometheus format. And it creates the metrics HTTP endpoint with information about the JVM and the whole NiFi instance. So we can check if everything is up and if our cluster of the NiFi works as expected. And it's really important because the NiFi under the load can cause a lot of issue, and well, it means also some money loss for customers or companies. But when we would like to add some of our custom metrics, it's the best to create custom NAR. And in our projects, we wrote our own NAR processors that helps us in counting the number of the flow files and some business metrics. And it's really simple also to add the NAR file to the NiFi instance. The next thing is the Bash exporter is absolutely the simplest thing, but it's also designed only for the simplest use cases because it helps in exposing the metrics. So we write the Bash script, and for example, we check if some conditions are met. And then, for example, we expose the metric with the value 1. That would mean that some service works as expected, and that's absolutely the simplest solution. But it's okay. For example, when we would like to check if some process on the instance works as expected, and here you can find that it's simple. I would say even too simple. The next thing is about using also the Bash exporter for exposing some Hive Query. And well, it depends also, because when we talk about the small number of queries, it's okay, but in different, it would be even better to use the PyHive, create your own exporter that will export only the column with the name, for example, the counters, and that will be exposed to the Grafana. And then you can create the valuable dashboards in the Grafana. So there are several approaches, and each depends on the use case and how many data you would like to expose to Prometheus. The next thing is about the monitoring Flink. Flink has available the Prometheus exporter. So you can really easily implement even your own metrics, and you can check the lag of the processing, number of processed events, and also validate the number of the restarts. As the next step, you're able to create the the restarting policy. So in case of the number that, in case of too high number of the restarts of the Flink, that it will trigger some job that, for example, will restart the Flink job with the clear state, but well, that's only the example, because in our pipelines, we use these metrics to check the status and then trigger some actions that are done by Bash script or even the Ansible roles that helps us in maintaining the whole environment. And now it's time to Spark. And before Spark 3, we went with the statsd sync from the Spark job. Then we sent these metrics to the statsd exporter, where we add some mappings to the Prometheus format, and then expose it to the Prometheus. And it works really well. So that's the main reason why we stayed with this solution. But there is also some more. And it also depends on the use case and with which solution you feel the best, so with which you have the most experience, because you can also go with the JMX exporter and using the JMX sync, graphite sync, and then use the Prometheus graphite exporter. That works in quite similar way like the statsd exporter. And the last is about building custom exporter of the metrics. But from the latest release of the Spark, so the Spark 3.0, it introduces the following resources: the Prometheus servlet and Prometheus resource. But surely in some environments, the update pipeline can take a lot of time. So it's also okay to go with a different, a bit older solution. Now it's also time to talk, but only, I would say, a few seconds, to talk about the monitoring tools that we can find in the cloud. So in the AWS, we have the CloudWatch and CloudWatch logs for taking the logs. In the Google Cloud, we have the tools that are at present called the operations metrics and operations logging that are formerly known as the stack driver. And in the Microsoft Azure, we have the Azure Monitor Logs and Metrics. And choosing the right solution depends on the use case, because the cloud solutions are great when you talk about the POC or MVP of the platforms, because then the price of these solutions are okay. But when we talk about the production scale, when we have a great number of instances of applications or any different, it becomes really expensive. So it requires also the calculation which component, which service is the best, in which we have some experience, and how much time it would require. And now it's time for really short demo of the monitoring solution. So it's based on the Prometheus. So here you can find the Prometheus instance, some configuration, but well, it's only the demo, so it's the ephemeral instance. And it's also important to remember that the single Prometheus instance is not able to handle too high traffic or to load all of its database. When we talk about the database that size is over 160 gigabytes, and we have only the 2 cores and 8 gigabytes RAM machine. But in overall, Prometheus is really lightweight and great performant because it is able to handle all requests, even with a single instance, and when we scrap metrics from 2 environments. So as the example, I can tell you about the Prometheus instance that handles scrapping the metrics from 7 nodes from the Kubernetes cluster, 20 nodes from the HDP cluster, from 7 Flink jobs, from Kafka, from Hive, also scrapping some metrics from Hive queries, and it still can run the queries that is run by the users in Grafana. And now I think we can go to the next part, so the logs analysis. It's much more interesting because not so many companies has implemented it in the application side of the whole projects, because well, the Elasticsearch is well known when we talk the analyzing of the logs, but mainly from the business point of view. So the most known solution is still the Elastic Stack, and it's really great when we talk the cloud ones, because it can scale up, scale down automatically, so we do not have to maintain. Because well, from our experience, it's quite tough to have great performance and take all the metrics and have the Elastic is the most stable component, especially in terms of taking the applications logs, because in the business logs, it's still a great solution, and I'm not sure if there is anything better when we talk about the open source market. So Elasticsearch is a distributed open source search and analytics engine. And the most use cases is about logging, log analytics, machine learning, and well, all the stuff. But I would say it's mainly the buzzword because it's not required for something like this, adding the machine learning. But well, it sounds great. And it's also interesting that Elasticsearch supports taking the metrics from different components from the service by using the metric bit. And it works, it's okay, but I'm not sure if it's the best platform for doing something like this. And well, it's also also important to add that that it also requires adding some custom components. And I'm not sure if it's the best way to develop our own monitoring solution, because then we have the vendor log only to the Elasticsearch, and its format, it's not compatible. Because when we talk the Prometheus, it's compatible with the open census format. So the format that is supported at present, for example, by Google or Microsoft. And when we talk about reading the files in the Elastic world, we can go with the FluentBit, FluentD that I would recommend and there is also the FileBit. And from our own experience, there are some performance issue with the FileBit when we would like taking the logs, for example, from the Flink applications that process hundreds, thousands of events per second. And the next solution that seems to be designed for the application logs is Loki, and that is the solution designed and created by the Grafana. And it's quite similar to the Prometheus because also the query language that is used is pretty similar. And if you know PromQL, then you know also the LogQL. And that's naturally we'll have the short demo session with the Loki, and that's how it looks like in the Grafana. It's also important that you can add easily the Loki instance to the Grafana, so you do not have to have the separated instance for the metrics and separate for the logs, because you can have everything at in the one service. And the whole LogQL is really similar because, well, you can grab based on the content of the log file and also add the required label of the log line that is taken. And the log is the aggregation system, while the logs are sent to the Loki by Promtail or FluentD or FluentBit. And Promtail is the one service dedicated for the Loki, and it's also designed by the Grafana Labs. And it's also interesting that Promtail works on the Windows servers. So I think it's also important to mention about it. And Promtail supports, like the Fluent components, also the pipeline. So you can filter the log files and you can relabel them. To support the high availability of the Loki, it requires having the object storage. like the Google Cloud Storage, AWS S3, Microsoft Blob Storage, and also the key value database, like the Google Cloud Bigtable or AWS DynamoDB. But from the release 1.5, you can go with the beta version that uses the BoltDB shipper, and then indexes and chunks are stored only in the object storage. And it's a really great feature because in the on-premise world, you would need to go with the Cassandra and some object storage. And Cassandra added much more work in comparison to the cloud installation. And as mentioned in the official documentation, the high availability of the Loki based on separating each component. So the ingester, the querier, so that each Loki instance should be responsible for something different. That one will be responsible only for take the logs, while the different will be responsible only for responding to users, but will run the queries directly. And about the performance, because I think that's the most important. So in our one project, we replaced the Elastic cluster that consists of 10 nodes, and it had a lot of issue with reading all the log files and sending them to the Elastic. And also there was a big lag because during the heavy load, there was about from 5 to 10 minutes of the lag for the user. So it was really bad for users, and that was the main reason why we tried to go with the Loki, and we install the Loki in the production in the release 0.3, and it works because it reads all the log files that should be read, and it works much better in comparison to the Elasticsearch, even that it has 10 times less instances. But surely it's great for the application, but it's not great for running queries on the business logs. But for developers, operations administrators, I think it's one of the best because, well, it's simple and well performant and also works. So you do not have to spend hours or days on debugging why something doesn't work as expected. And it's time to talk about the differences between the Elastic Stack and Loki. And it also the main difference in the performance depends also on how all the data are indexed, because in Elastic you have a lot of options to index the data, while in the Loki you index only the labels of the log. So it's quite similar like in the Prometheus world, when you can label the metrics with the host name, source of these metrics, the name of the job, name of the application, name of the user, etc. And it works in a pretty similar way in the Loki. And the name of the Promtail comes from this, that it only tails the log, and it saves its state in the local file. And as Prometheus, Loki is also designed really well for the Kubernetes infrastructure. And the query language in the Elastic, we have the query DSL. When in the Loki, we use the LogQL. And now it's time also to show how the Loki looks like. So the first component is the Promtail. So I added a really simple bash script in the virtual machine that writes all the time log information to the local file, and I added some target labels. And that is added by me. That it's discovered labels. So it adds the address. So it's the local host because everything is installed only locally. And the second thing is the path from which the log is scrapped all the time. Here you can find that it is ready. And as you can see, even the whole interface of the Promtail is really similar. And I think that, here, the targets and targets here. Okay, so now we need to go to the Grafana, and I have added as the data source the Prometheus instance, the Loki, and the one hack that is really useful. So adding the Loki instance as the Prometheus data source to enable exposing the number metrics from the Loki. So for example, you would like to count the occurrence of some phrase in the log file. So for example, you have the Spark job and you would like to check when and how many times some word occurs in the log file. And then, for example, you can trigger the alert. And as you can see, we can go to the Explore tab in the Grafana and choose the log labels. So that's the default job that is added in the example configuration of the Loki of the Promtail, that it scrapes all the log files that are in the var log. But I would like to go with something different, so I would like to the app random that is generated by the random script. And now I would like to check how many of these log lines are errors, how many are warnings, and how many are info. And Loki supports labeling all of them, and it reads from the beginning of the log line. What is it? Is it error? Is it information? Is it warning? Or what is it? And then you can easily get the great data visualization, because you can easily find what is going under the hood. And it's really useful also for developers, because you can add, so I would like to find the log that has also the word, for example, Flink. So I need to go with the run query, and now I can see only the log files that consists the line with the Flink in it. So as the next step, I would like to add some dashboards based on the metric. Now I can go here, and here I have added some dashboards. And that's the simple table in which I displayed all the log lines that consists the word Spark. Here I have added the simple counter for counting how many lines are there from last 1 minute. So we check that from 1 minute, we scrape that each minute we scrape 72 lines of the log. And we can also check the number of the occurrence of the word Kubernetes. And well, it doesn't look great because I have chosen the wrong time interval. And here I defined the count of the logs for the last 5 minutes. And in terms of the data processing jobs, we can count any occurrence that we need and in which we are interested. And then we can add the alerts. That is the killer feature for many use cases and for many projects. That's the end of the Loki demo. And why and how to implement the log analysis. So I think that in any project in which we process data or in which we run a lot of applications, it is required for applications. It is required to have the central location for storing logs, because it's much simpler to go to the one place instead of going to each instance and check, for example, the Hive server logs. Because you can query this data, you can check only the errors, and you can do it much faster. So you can save your time and make your work smoother. And well, I would say that it's also more comfortable. So I think that's the killer feature for absolutely any user. And it's also important to define the real needs of the users, because then you will be sure that you should go with the Loki or Elasticsearch or any different solution that you can find, or even with some logs analysis tool that you can take from the public cloud providers. And there is also one article that I have written about the log analytics that you can find in the GetinData blog. And also you can download the whole white paper about monitoring and observability for data platform where, well, I have described all the thing, but with more details and with some use cases and example of the architecture. So I think that's all from my side. So it's quite good time because, well, I spent only 45 minutes on talking all the time. So I think now it's time for questions. If you have any, do not hesitate to 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 tell them. Thank you for your attention. What's the performance? Okay, and as you mentioned, log indexes only metadata. I assume it allows for searching through the messages. What's the performance on that? So that's really important to add more labels. So for example, based on the file names. As the example, I can tell you about taking the log files from then it was 5 Flink jobs. So the Loki was able to only one instance of the Loki with 4 cores and 16 gigabytes of RAM. It was able to run the query based only on the one label and with several grabs. It was able to run the query on the data from the last 3 hours, and this query took about 40 seconds. Because when we talk about the running queries on older data, then we need to set the higher timeout for the Loki, because the default, as I remember, I'm not sure, is 60 or 120 seconds. So it's really important to add labels designed for the queries that will be run by the developers or that will be used for creating dashboards. Okay, now it's the next question. So. Yes, we have also researched the different, especially the Datadog, but the price of the Datadog in one project was even higher than the CloudWatch. So, that there is also some issues with the with the documents that they have shown us. So the overall price, it was not okay to compare in comparison to the CloudWatch. Have you looked into total cost of ownership, including hosting and dev time required for setup, glue, and maintenance versus other options? And we have analyzed. So that is also the main reason why in some cloud projects we stay, for example, with the cloud operations and formerly the stack driver, because it was okay for the customers, especially that they do not have many components. But in the on-premise world, I wouldn't say that there is anything, well, cheaper and better performant. And also, it's also important that we can easily add our own exporters, and it works smoothly. And about the costs of the whole infrastructure, we calculate the metrics and logs services, because, well, it's important, and we implement both of them in our platforms, especially that we have some experience in it and we see great advantage. Even when it requires more work. But well, when we talk about logs, it quite simple. Yeah, and logs. And as you can see in the Zoom chat that the logs are regular about cost. So that's the reason why Loki is okay for developers, because you can easily check some logs. But for the business analytics, still Elasticsearch is the king, and I don't think that the Grafana labs would like to compete with them, especially at present when the Elastic has a lot of options to install, and the AWS publishes the open distro of the Elasticsearch with all the features that earlier was only available in the paid version. Mm-hmm. And what is the size of your fleet? You are monitoring hosts, VM, kube clusters. So well, it really depends. So I think that I can tell you about the two last projects. Both of them are based. One is the on-premise infrastructure, and the different is the hybrid one. So in the production, we observed that 20 workers in the HDP cluster, the 3 masters. And there is also some 5 or 6 additional virtual machines for developers and for some BI developers. There is 2 kube clusters from we scrape the metrics, but the biggest impact of the whole performance is related to the application, from which we have to scrape a lot of metrics. And in the second project, we have the 70 servers in the HDP cluster, 3 servers, and the whole cluster is divided into 3 regions to provide the high availability. So it also means that we are more scrapping some metrics depends more also on the network issues. So that's the next disadvantage of these pool-based models. But yes, that monitoring hundreds or thousands, it's okay, unless, for example, you would like to monitor production and development or QA environment only from one instance, because it's not designed for having everything, but it's much better to have separated the Prometheus or Loki instance. And are you seeing problems with Prometheus pool model at your current load? Do you expect it in the future? Yes, well, I expect it in one project, so that's the main reason why we decide to go with migrating this simple high availability setup of the Prometheus to Thanos, to have separate each part, to also reduce the load only on the one Prometheus instance, and also divide our setup to make it more scalable. And also we would like to have more older logs to make some reports. So I would say more business things, and also creating more metrics. So something that is described in all site reliability engineering books, articles, and all the stuff. And well, now it's called the observability, but well, some years ago I would call it the monitoring solution. How experienced dev time is it to maintain the monitoring solution, and how reliable is it? And well, about the reliability, I think the only time that we spent on maintaining it is about the upgrading to the newer version. So it's still quite simple, and as I remember, I have upgraded the Prometheus 2.3 to the 2.15 in the production environment. in less than 1 hour. And it was also with the time that we use for checking everything, but it was on the on-premise and we use our own Ansible roles. And in the Kubernetes, it also doesn't take much time. But it also depends on the version of the architecture that you would like, because installing everything with the simplest solution, so using two Prometheus instance or using even the single instance with local storage is really simple. So you can create the configuration file, install it in less than 2 hours, also to configure all the stuff. But when we talk about adding the full high availability, then we need to take care of object storage and installing all the stuff. So it's also about permissions, creating the service accounts and all the stuff. So it also depends on the project, on the security model that is required, and also in which environment. Because in public cloud, it depends how many things we would like to monitor. Because when we do not have much things, well, it's okay to go CloudWatch, Google Cloud Operations, or Azure Monitor, especially that you can have your own Grafana. That is, in my opinion, that is more useful for developers in comparison to some solutions that are delivered by the public cloud providers. And there is also the plugin for the Grafana to take the Stackdriver metrics or to take the CloudWatch metrics. And then you can have the hybrid solution, and it works it works okay. And in one project, we went with taking the monitoring of the whole infrastructure. So taking the EC2, EBS, S3. So, and we took it from the CloudWatch and create the dashboards in the Grafana, while the applications were monitored by the Prometheus. So there is also an opportunity to go with a kind of hybrid architecture, and it's still quite simple to add custom exporters. Yes, and well, I also use in one project the Datadog for monitoring, and well, the Elasticsearch. Okay, well, quite interesting setup, and well, yeah, because in one project I also use exactly the same, but well, it was all mainly caused by some business decisions. Okay, thank you very much. So, well, I see that that's the end of the questions. So, well, if you have any questions, if you will have any questions in the future, you can contact me. Well, you can easily find me in the LinkedIn, Twitter, or anywhere, or you can write to the GetinData, and we'll try to answer your questions. So, well, I think that's all, and I suppose that I will also share the presentation soon in the internet. Because, well, I'm not sure if I will not forget it to do it. So, well, I think that's all. So thank you very much for your attention. Have a great day and take care. Bye-bye.